Hello everyone, this is Super CEO. Welcome to video number 6. And today, again, we're going to do only just one question. But again, this question alone is very uh, long, I think. So it's going to take another 10 to 15 minutes of um, application of integration using continuous random variable. All right, so as usual, this is the statement from Cambridge. All right, so today's question is this question number 13. And given this little frequency function with the domain being 0 to 1, and part A sketch the frequency function, and then part B find C, given that that little f of x is a PDF. So in B, we were told that it's a PDF. So now in this question here, the funny thing is C is not actually defined whether it's a positive or negative. Now, because of part B, we are going to assume without much loss of generality that C is going to be positive. Okay, so I'm going to explain that more in detail when we do part B. In part C, find the CDF, and D, you have to find all those quartiles. All right, so let's get into the business. Okay, so very first question. So again, I've rewritten this the frequency function. So that's that one. That's the given domain. Now, assuming fx is to be a PDF in part B, and we're just going to assume that C has to be positive because of that reasoning. Okay, exponential function, whether it's an e to the x or e to the minus x, is always going to be positive for all values of x. Okay, so now, as you remember that one of the conditions for this function to be a PDF, this whole thing has to be positive, at least in that domain. Well, that e to the minus x is always positive, so then C has no choice then other than being a positive number. So it's therefore we can pretty much assume that C is going to be positive. Hence, if that's the case, then we can sketch like so. So the initial value for f of x is going to be f of 0, obviously, because the domain starts at 0 and e to the 0 is always 1. Hence, that's c. And the end value is c e to the negative 1, which is c on e, which is that one. So it's decreasing like so. So that's part A. And part B. Now, we've ticked off the very first condition of a function being a PDF, which is that has to be positive. And part B is to fully prove that it's a PDF. We're going to have to show that the integral from 0 to 1 of that little f of x is equal to 1. So that has to be true. So for that to be true, then this leaves us this statement. So the primitive of e to the minus x is, yes, you get the e to the minus x back, but also reverse the chain rule says you have to divide by the derivative of the negative x with respect to x, which is negative 1. So you get this, and evaluate it from 0 to 1 gives you 1. Now, this is one of my favorite techniques that I always use, especially when my primitive has a negative in front. I mean, you don't have to do this, but I always do this, is that I'm going to drop this negative sign and then reverse the order. And the reason that makes me do that is because of that argument. One of the properties this is only true for the definite integral, is that if you swap the order of integration, then that's going to spit out the negative sign, and then the A and B get swapped. Okay, so that's that one, because you can think of that as summing it from left to right, whereas that one is the summing it from right to left. Hence, you have to reverse the original sign to get the same integral as a definite integral. Okay, so that's my thing here. Again, you don't have to do that. So that means evaluate it from 1 to 0, not 0 to 1. 1 to 0 is going to give you this, because that's going to be c times 1. Take away c over e, which is 1. So now you solve for c, because you have to find out the value of c that makes this thing equal to 1, so that that little f of x becomes a PDF. So carrying on your algebra, so c is a common factor, so taking it out then leaves us with 1 minus 1 on e equals to 1. And because you're solving for c, you can now divide everything by that stuff inside the bracket, which leaves us with this. Simplifying, what's in the denominator is e being the common denominator for that, and then it leaves us with this, and flip that around, then you get that. So that has to be the c value in order for that c to the e to the c e to the minus x to be a PDF. So now part C is to find out the CDF. So that's now big F of x, meaning that's the integral, or to be more precise, a primitive of that little f of x. Now, the catch is, as I always mention, yes, starting point of the domain and not the end point of the domain. That now has to be left as x. And the PDF now becomes a function of t, and then that becomes dt, not dx. That's important because you need to integrate this with respect to t. So again, same algebraic structure that it carries with what we had previously is that minus c e to the minus t, evaluated from 0 to x. Again, dropping the negative sign and then swap the order, then you get this. Then it becomes c, take away c over e to the x, taking the c out as a common factor, and that's now that. Notice then this becomes, as expected, a function of x. Okay. All right, now we've figured out what the c has to be from part B, and that is e over e minus 1. So I mentioned it there again, just as a reminder. So that's from B. Hence, you can now fully write f of x without any c. So that's e over e minus 1, bracket that. Okay. Now, part D is the main part of this question. The entire question is you have to find all these quartiles. So median is half. So you can set that function equal to half. So all of a sudden it now becomes a equation to solve, 4x. So therefore divide everything by this, e over e minus 1, then you get this. Okay, so then it's 1 minus that. And now I'm going to make this 1 on e to the x as a subject. So that means that gets over to the other side, which means that term now has no choice other than moving on over to the other side. So it leaves us with this common denominator, simplifying, then you get that. Okay, so remember this is 1 over e to the x. So therefore, e to the x, which is the reciprocal of this, is basically swap those two, flip it, then you get this. Now, once you've got this, remember we're trying to find out the x. So, using the log definition, then you get this. Now, as a reminder, this is how the log is defined from its corresponding exponential expression. So that's that one. Then we know that. And special cases, when the base is 10, the common log is usually written as log a or log a. And with the natural base e, then it's usually written as ln a. So here ln means log of base e because the original exponential had the base of e. So that's that. And now that becomes Q2, the median. And similarly, you can now carry on to finish off with Q1, lower quartile, and Q3, the upper quartile. So Q1, the lower quartile, is the quarter mark. So instead of half, you now set that as a quarter. Carry the similar algebra along that we did for the Q2. Then you get this. So just number now changed to 4. Okay, 1 on e to the x being the subject, then you get this. Common denominator will leave us with that. Again, flip that to get this. And again, to solve for x, you have to use the log definition, which will give us this. Then that's now your Q1. And similarly for Q3, so that's now 3/4 point. So instead of 1 on 4 or half, it'll be 3/4. Okay, so again, one more time, divide everything, both sides by e over e minus 1, and then you get this. So notice this gets multiplied by 3 for both of these two terms. So there's 3 minus 3. And 1 on e to the x, now the new subject, then leaves us with this. Common denominator now is 4e, there's 4e take away. So be careful with that one. That becomes now positive because negative times negative is positive. So that's this. And again, using, so therefore that's 1 on e to the x. So therefore e to the x then will be swap of the reciprocal of those, reciprocal of that fraction, which will give us this. And then using the log definition, then you get that. Okay, so that's the Q3. So that concludes our video number 6, and I'll see you guys next time.